Today I am going to solve the problems of Neet 2026. My main objective is not only to solve these questions. Actually, this I had discussed with my students, and today my objective is that something different. Here I do not want to prove my talent that I am solving the NEET paper 2026. This is not my objective. My objective here is something different which I want to tell every student, because last 4 years I have solved this NEET questions papers, not only NEET questions papers, JEE mains and our CW papers. What the conclusion I have got that I want to tell all the students. Now see here the first question which I have taken from this NEET 2026. One main scale division of a vernier caliper is equal to 1 mm and the number of division on the vernier scale is 10. When both the jaws touch each other, the vernier scale shifts to the left of the zero of the main scale in such a way that the fourth vernier division coincides with the division of the main scale. If this vernier calipers measures the length of a wire to be 1 centimeter, the actual length of the wire is. Now you see this question. This question is within your textbook. This is within your textbook. You have solved such type of questions, not only theoretically, but you have also done practical to find the least count. So I want to ask the students that is this question out of your syllabus, or out, not only out, but strictly out of your textbook. It is inside your textbook. It is fully inside your textbook, and you know that the vernier calipers, what is the importance of vernier calipers, that it can measure up to 2 decimal places, up to 2 decimal places. So here you all know to find the least count, because you have even done in your practical. You have already, not only theoretical, you have also done in practical. So here your least count, here it is given that the main scale division, it is 1 mm, and the vernier scale division, there are 10 divisions, it is given to you. So your least count is 1 divided by 10, and that comes out to be 1.01. That is your least count. So you have already you know this calculation. You have done this. Now since here the question is that the vernier scale shifts to the left of the zero of the main scale in such a way that fourth vernier division coincides with a division of main scale. So here there is a zero error. That means the vernier scale, its fourth division coincides with the zero. That means its fourth division. The fourth division is lying on your left side. So that is your error. So your error formula is minus bracket number of divisions in the vernier scale, that is 10, minus the division of the vernier scale which coincides with the main scale, that is 4. So it comes out to be 10 minus 4. So this is your into least count. So into least count 0.01, that was your least count was 0.01 centimeter. So your least count is minus 1.06 centimeter. So here your actual reading will be 1.06 centimeter. So such type of questions you have done. So I want to, my main focus is that this is within your textbook. You know to calculate the least count, that is one main scale division divided by the number of division in your vernier scale. This gives the least count. And second is, since your vernier scale 0 does not coincides with the main scale 0, that means the vernier scale it has shifted to the left, towards the left, and your fourth division of the vernier scale coincides with the 0 of the main scale. So this 4 division towards left is your 0 error. So to calculate the 0 error, that is minus bracket number of divisions in the vernier scale, that is 10, minus the division which coincides with the main scale, that is 4, and into least count. So if you, this is your least count. So from your reading which was given to you, that the length you got 1 centimeter. So its actual reading will be, you have to minus that error. So 1 minus bracket minus 1.06, it comes out to be 1.06 centimeter, which is the actual reading. So my main aim is here to focus the student that it is totally within your textbook. Now our next question. In a solar system, the time period of revolution of a planet tracing a circular orbit of radius r is proportional to. So you have read in Kepler's law, this is within your book, that t square is proportional to r cube. So t is proportional to r to the power of 3 by 2. This is a very easy question, and it is clearly given in your textbook. Now the next question here is, consider that sigma s, k, b and b represents the Stephen-Boltzmann constant and Wayne's displacement law constant respectively. The dimension of Stephen-Boltzmann's constant, that is sigma s, into Boltzmann constant to the power minus 1 into small b, that is Wayne's displacement law constant. What is the dimension? You have to find out the dimension. So see, it is clearly within your textbook. You know that in your Stephen-Boltzmann constant, where it is in your radiation chapter, that is black body radiation, where E is equal to sigma t to the power of 4. So here your sigma is the Stephen-Boltzmann constant. And now the main trick which has been applied here, that the Stephen-Boltzmann constant and Boltzmann constant. Your Boltzmann constant Kb is from your perfect gas equation. This is from your perfect gas equation. But Stephen-Boltzmann constant is from black body radiation. And Wayne's displacement law, it is from your radiation chapter. Only the trick which has been applied in this question is Stephens-Boltzmann constant and Boltzmann constant. So here your Stephens-Boltzmann constant is from black body radiation, and your Boltzmann constant Kb is from your kinetic theory of gases. This is the trick they have applied. And your Wayne's displacement constant, you know that lambda m into t is equal to constant, that is b, and your Boltzmann's constant, that is pv by capital N into t. N is the number of molecules. So from here, that is Kb is equal to pv and t. So from that you can find out your Boltzmann's constant. When you know this formula, you can easily find out the dimension of it. So repeatedly I want to tell only the thing that your thorough study, that means your class 12 and class 11 textbooks, not only physics, your maths and chemistry, all these textbooks, you have to go repeated revisions, and the repeated revisions will make you more clear, you'll make the topic more clear, and that is my main focus here. Now again, 1 mole of an ideal non-monoatomic gas undergoes a cyclic process, and the figure it is given on the question. The total heat supplied to the gas. Now your total heat supplied to the gas. So here the graph is given between pressure and volume, and a cyclic process, a rectangular cyclic process is given to you. So you have to find the heat supplied to the gas. That means you have to find the work done. So you know that work done, that is equal to P into dV, that is change in volume. So from this formula, P into dV, and the graph it is given between P and V, you can easily find out the work done. So this is also a very easy question, and it is totally within your textbook. Now the next question here is, in an adiabatic expansion, the temperature of 1 mole of an ideal monoatomic gas, gamma, is equal to 5 by 3, decreases from 60 Kelvin to 50 Kelvin. Work done by the gas in the process is, you have to take the value of R, it is given to you 8.3 joules per mole per Kelvin. So I am again repeating the question. In an adiabatic expansion, the temperature of 1 mole of an ideal monoatomic gas, gamma, that is equal to 5 by 3, decreases from 60 Kelvin to 50 Kelvin. The work done by the gas in the process. So adiabatic expansion or isothermal expansion, adiabatic compression or isothermal compression, it is in your chapter thermodynamics. So it is in your chapter thermodynamics, and in your textbook it has been clearly defined, given to you, that the work done by when 1 mole of a gas expands adiabatically and its temperature falls from T1 to T2, your work done formula is equal to N into capital R into T1 minus T2 divided by gamma minus 1. Here N is equal to 1 mole. So this is from your thermodynamics chapter, and it has been clearly explained in your chapter. Work done in an isothermal expansion, work done in an adiabatic expansion, work done in an isothermal compression, work done in an adiabatic compression. And if for 1 mole of a gas, it has also been clearly explained to you, it has been clearly given in your textbook, and which is equal to N, that is number of moles, into capital R into T1 minus T2 divided by gamma minus 1. So all the datas, gamma 5 by 3, fall in temperature from 60 to 50, fall in temperature from 60 to 50, all these are given to you. All these are given to you. So you can easily calculate the work done. Just you have to put the values. There is no trick. There is nothing trick here. Just you have to put the values. The only thing is that you must remember the formula, that is the work done in an adiabatic compound. This is expansion, work done in an adiabatic expansion, which is clearly given in your thermodynamics chapter. So this is fully within your textbook, and it is in the limit of a student. He can easily solve it. Now the next question again is that an ideal gas is made of polyatomic molecules. Each of the molecules has 3 translational, 3 rotational and F number of vibrational modes. If the ratio of heat capacity Cb by Cv of the gas is 8 by 7, then the value of F, that is the number of vibrational mode, you have to find it out. So your formula is Cp by Cv, that is equal to 4 plus F, that is the number of vibrational mode, divided by 3 plus F, that is the F, it is the number of vibrational mode. The formula, only this is the formula, you have to just place the data here, and when you place the data here, you get the value of F, which comes out to be 4. So again, I am repeatedly wants to tell every student that first of all read the question and you analyze it, that this is within your textbook, fully within your textbook. You have to, there is no need, from my point of view, you may go for other references, that is up to you. You may go for other references, whatever you like, you go to you. But what I want to tell the students, that first of all, you make a thorough study of your textbook. Repeated revision is necessary. Repeated revision is necessary of your textbook. Then it will become very easy for you. Now the next question here is, a car travels on a circular racetrack of radius 5 meter, which is banked at an angle of theta. If the car travels at a speed of 10 meters per second, then the wear and tear on its tire is minimum. Taking the acceleration due to gravity to be 10 meters per second square, the value of theta is. So, in case of banking, you have read in class 11 in case of banking, that is your for minimum wear and tear, your tan theta is equal to V square by Rg. For minimum wear and tear, your tan theta, theta is the angle of banking, that is the road which is making an angle theta with the horizontal, so that the car can easily take a turn. And your tan theta is equal to V square by Rg. So here again, everything is given to you. Your V is given to you, your radius R is given to you, and even acceleration due to gravity is given to you, and you can easily find out the theta angle. Now then your next question is, consider three media P, Q and R with refractive indices 1, 1.25 and 1.5 respectively. The medium Q having a thickness of 5 cm is placed between the extended media P and R as shown in the figure. An object Q is placed at the center of the medium Q. If viewed from both the medium P near the normal direction, the apparent depth of Q is H1. For the similar observation from medium R, the apparent depth is H2. You have to find the value of H1 minus H2. So here I want to tell the question in a nutshell that there are three mediums. At the top, its refractive index is 1, and in the middle its refractive index is 1.25, and at the bottom its refractive index is 1.5. An object is placed in the middle medium where the refractive index is 1.25. Now, if you view it from the top medium, your refractive top medium, you have to find out the apparent height, and when you view the same object which is situated in the middle from the bottom medium, your apparent height is H2. So you have to find out the difference between H1 and H2. Now here again you see that H1, you know the formula that apparent depth is the real depth divided by the refractive index of the medium. You know this, that the apparent depth is the real depth divided by the refractive index of the medium. This is clearly stated in your textbook. This is clearly stated in your textbook. And next you know that the refractive index always with respect to another medium. So when you view it from the top, that is your refractive index of the middle portion with respect to the top. Your refractive index of the middle portion is with respect to the top. So here your refractive index of the middle medium divided by refractive index of the top. So these are the two formulas which comes when you solve this problem. First of all, the apparent depth is equal to real depth divided by the refractive index of the medium. And you know this line is clearly stated in your textbook. And again you know that the refractive index of a medium with respect to another medium is equal to the refractive index of the medium in which the ray enters. That refractive index is on the numerator, divided by the refractive index of the medium from where the light ray comes. The refractive index of the medium is in the numerator. It is where the light ray, the medium where the light ray enters, divided by the refractive index of the medium from where the light ray comes. So, taking these two formulas, you can easily find out H1 and H2, one when you view from the top and the other when you view from the bottom. So here the refractive index of the medium, the middle medium, when you view from the top, it is 1.25, and the refractive index of the middle medium when you view from the bottom, it comes out to be it comes out to be 1.25 divided by 1.5. So when you calculate it, you will get the refractive index 1.25 divided by 1.5. You will get the value, and by this you can find out the apparent height H2 when you view it from the bottom of the medium to the middle medium, and by this help you can find out the value of difference between H1 and H2. So this refractive index you have also read in class 10 also. In class 10 also it has been clearly given that refractive index of a medium with respect to another medium, that means equal to the refractive index of the medium in which the light enters, is in the numerator, and the refractive index of the medium from where the light enters is in the denominator. Now again, your next question is, two infinitely long parallel conducting wires A and B carrying current I and 2I respectively in the same direction. The wire A has uniform mass per unit length lambda, and it lies on an insulated floor. The wire B is kept fixed at a height h above the floor. The minimum magnitude of h so that wire A does not rise above the floor. So here the question I want to tell you, there are two wires, and there are two wires. Wire A, which is lying on the ground and on an insulated floor, and I current is flowing through it, and above it at a height h there is another wire which is carrying 2I current in the same direction. So we know that when the current are flowing through the wire in the same direction, there is attraction. And the next theory, we know that a current carrying conductor, it at any point it produces a magnetic field, and that magnetic field is given to you by Biot-Savart law, that also you know. And now the question here is, why the wire of mass A has uniform mass per unit length lambda? Why the mass of the wire A, it is given to you which is lying on the floor, on an insulated floor, and another wire which is above it at a height h, carrying 2I current. And since both the current are flowing the same direction, we know that there is attraction. Here the mass it is given to you, that is for wire A, that means from where you get the weight which is acting downward, and there is a force of attraction between the wire B and A which will move in the upward direction. and the weight of the body will move in a downward direction. So here it has been asked that the minimum magnitude of H so that the wire does not rise. So the force of attraction between the two wires must be equal to the force, gravitational force on wire A acting downward. So again you know that where this also the formula, it has been clearly given to you that the force acting on, there are two conductors which are carrying current I. So the force exerted by let us, it has been given in your textbook, there are two conductors. One is carrying IA current, another is current IB current, and the distance between them is D. So the force exerted by uh, your A wire on B, that is equal to mu naught IA into IB divided by 2 pi into D into the L, length of the conductor. You know this formula. So you have to apply this formula. This formula must be equal to the weight of the wire A, which is lying on the floor. When you equate it, you will be able to find out the distance, the minimum height between wire A and B. So here you see that these formulas are clearly given on your book. And second, that is the weight of the, you all know the weight, how to calculate the weight, that is mass into G. So the wire A, so that the wire A does not lift, that means your weight of the wire must be greater than or equal to the force of attraction between the two wires. And you know that when two wires flow in the same direction, there is force of attraction, and the force exerted by wire A on B, that also formula you know that, because first of all you have to calculate the magnetic field which is produced due to A on B. The magnetic field that is produced on A due to the current flowing on A and on B, and when you find out the magnetic field, then into IA, that will give the force acting on the conductor, which the formula at last we are going to use. That this also, it has been clearly stated in your textbook that a current carrying conductor is placed in an external magnetic field. A current carrying conductor is placed in an external magnetic field. The force exerted by the external magnetic field on the current carrying conductor, that is equal to I L vector cross B vector. So all these things are given in your textbook, and you see the questions. These questions, there is no trick. They have applied no trick. They are only the simple questions. They are the simple questions. That means such questions can also be asked in your 12th final exam. Such questions can also be asked in your 12th final year exam. Now your next question here is, consider an electron is revolving in an excited state of hydrogen atom with velocity root over 25.6 into 10 to the power of 5 meter per second. The radius of the orbit is x into 10 to the power of minus 9 meter. The value of x is. So here again the electron is revolving in an excited state of hydrogen. atom. So revolving, that means here there is a Coulomb force, and since it is revolving in a circular orbit, it is that Coulomb force is nothing but the centripetal force, and if you equate the centripetal force with the Coulomb force, you get the formula for radius, which has been clearly given in your textbook in the chapter, most probably atoms, it is given to you. And the formula of R is equal to E square divided by 4 pi epsilon naught mv square. So it has been clearly given to you, and most probably it is in the chapter atom, and there is nothing tricky in it. Everything has been clearly written in your textbook. You have to just place the data and you will get the value of x. Now here again a question, that is, a particle of mass m moves along a horizontal x-axis from x is equal to 0 to x is equal to L. The coefficient of kinetic friction varies as a function of x, and the coefficient of kinetic friction, the relation it is given to you, constant of appropriate dimension are constants of appropriate dimension, so that your kinetic friction at x is equal to L is your 0. The work done by the frictional force, you have to find out the work done by the frictional force, it is given to you. So whatever, to find out the work done by the frictional force, here you know that in work done, first of all, the important point here is the work done. Here your force must be a conservative force, and at the same time you know that when there is a work against existing force, whenever there is a work done against an existing force, this is the two important point which has been clearly stated in your textbook, repeatedly stated in your textbook, that in work done your force is a conservative force, and whenever there is a work against an existing force, you have to solve it by the help of integration, that is the integration, and in here you consider the acceleration is 0, and we consider a very small displacement, such that your external force is equal to the resistive force. So in such type of cases, so remember that whenever you have to find out the work done against existing force, so in such cases we have to go for integration. And second is that, and the second factor is that in work done your force must be a conservative force. So the same thing is taking place here. So work done you have to find out by the frictional force. So instead of frictional force, we are going to, that is coefficient of static friction into G, that into weight, into that is normal is nothing but the weight of the body, and we know that the gravitational force is the conservative force, and if you integrate it from 0 to L, and to find the value of A, it has been given to you that your static friction at L is equal to 0, and when you apply this you will get the value of A, and when you integrate it from 0 to L you will get the solution. Now my next question here is that a current I0 flows through a metallic circular loop of radius r as shown in the figure. Resistance of segment ABC is half that of ABC. Magnitude of magnetic field at the center of the loop. So the formula for the magnetic field, it has in Biot-Savart law, in its application, it has been clearly proved and it has been clearly given that when a current is flowing in a circular loop, the magnetic field at the center of the loop is nu naught I by 2r, nu naught I by 2r. This has been clearly given in your textbook. You have to use this formula. At the same time, here what is happening that in the segment 1 ADC, the current is here the current I naught flows through a metallic circular loop of radius r and radius r as shown in the figure. Resistance of segment ADC is half of the resistance ADC. Here resistance is half. So by the help of, since the current is inversely proportional to resistance, the resistance, so by applying this, we get a ratio between I and R, that is I1 by I2, that is equal to R2 by R1, and we get the ratio is equal to 2. When we get the ratio between I1 and I2, which is equal to 2, we can, that means total current I is flowing through the loop. In ADC, your current will be, because we know the relation between I1 and I2, I1 is to I2 is 2:1. So I1 is to the total current I naught will be 2:3, and I2 with respect to the total current will be 1:3. That is I2 with respect to I naught. I2 is to I naught will be equal to 1:3. And by the help of this, you can find out the net magnetic field at the center of the loop. The main formula here which we are going to use, that is in your chapter, that is Biot-Savart law, it has been clearly given that the magnetic field at the center of a circular loop carrying current is nu naught I by 2r, where r is the radius of the circle, dot I cap, it is the direction. So now next question here is, an AC voltage V is equal to 220 sine into 2 into 10 to the power of 3 t volt is applied to a series LCR circuit. The current amplitude in this circuit is, so current amplitude, it has been clearly given in your textbook, that is Im is equal to Vm by Z. Z is the impedance, and your Z it is equal to root over R square plus Xc minus XL the whole square. So to find out Xc, we go for the formula 1 by omega C, and for XL we go for omega L. And here your omega, it is given to you in the V equation, that is omega is 2 into 10 to the power of 3, because V is equal to A sine omega t, and here your omega is 2 into 10 to the power of 3. It is clearly given to you. And at the same time, your capacitance and inductance is given to you. From here you can find out the value of Xc and XL, and it comes out that the Xc and XL are equal, so it is purely a resistive circuit, and you can easily find, and Vm it is 220 volts, so you can easily find out the current flow Im, and which comes out to be 2.2 ampere. So again you see that, again the same thing. It is totally from your book. It is totally from your book. Nothing from any reference book, nothing you have to think a deep. There is no need of, in every question you see that neither deep thinking is required, only the work which you have to do, which I want to repeatedly tell all the students, that you thoroughly study your textbook, go repeated revision, and this repeated revision will clear all your doubts. At the same time, it will make you more perfect in solving your problems, and it will bring you more confidence. Because when you follow your textbook, every formula, it will be before your eye that this formula is from this chapter, and this formula is related with this where this variables, and what is the meaning of each variables, and what is the unit of each variables. All these pictures will be before your eyes, and which will make you help to solve the problem. Again, a bob M of mass m at rest is hanging vertically from the ceiling via a massless string of length 10 meter as shown in the figure. Point mass A of mass m traveling horizontally with speed 10 meter per second hits the bob B elastically. The bob rises h meter after collision, taking the acceleration due to gravity g is equal to 10 meter per second, and neglect the size of the bob. The value of h is. So here in your textbook in class 11 in the chapter collision, elastic collision, it has been clearly stated, if two bodies of same mass, one is at rest and other is moving with a velocity v, strikes the ball at rest, the ball moving with velocity v will comes to rest, and the rest ball will take the velocity of the, means, let me tell it in a different way. Let there be two bodies of mass, let there be two balls A and B, let there be two balls A and B, and here the mass of A and B are equal. Mass B is at rest and mass ball A is moving with velocity v. When it strikes the ball which is at rest, the ball A, it comes to rest, and ball B, it takes the velocity of ball B, it takes the velocity of ball A and moves forward. So this has been clearly given in your textbook. So from using only this simple theory, and we know that when it moves up only acceleration due to gravity, and your initial velocity you know, to the maximum height it can rise, the final velocity will be 0. You know g, and you can find out the value of h. So here again, so this there are all these questions. I want to compile here itself. I want to stop it here itself. I want to repeatedly tell every student that I want to tell every student that for your competition, either it is Neet, JEE Mains or your CW, you first of all go a thorough study of your textbook, make repeated revisions, and eh, the doubts will be more after every revisions your doubts will be more clear. Do maximum problem sum, do maximum problem sum, and better you confine to your textbook, because this textbook will help you that the formula from which chapter it is, and the formula, the variables related to the formulas, what does it actually means, and its derivation, how it was derived, everything comes before your eye, and it becomes easy to solve it. So here I do not want to show my talent, nothing, there is nothing about it. Because these questions, there are, you will find in the network, in the internet, all these questions are available, your answers are available. So I just do not want to expect, I do not want to show any talent, or I have done such thing, I do not want to show this. The only thing I want is to focus the students on the textbook, to focus the student on your textbook. That's all for today.